As you guys know, lunch is at 11:45, and coffee and drinks are always out there. After lunch, what time do you have to, I'm sorry, I can't see without my glasses, so pardon me, I'm blind as a bat. So lunch is from 11:45 to 1, and then we'll have an afternoon break at 2:30, so you guys can feel free to get some more coffee or whatever at that time, and it'll be done at 2:45, so we want to be back here prompt because I got card tricks and jokes and maybe. I might have to get some cards. But before we get started, does everybody know everybody in the room? Has everybody met everybody? If you haven't, except for the last row, everybody turn around and just kind of introduce yourself to the person behind you, just so you guys can kind of do that for just a couple minutes. And pass out cards if you'd like, but it's a good icebreaker.
I'm now independent. I used to work for Intel.
Okay. I used to work for
Where? Oh, Qualcomm.
Yeah, Qualcomm and this.
I see. Hi.
Welcome.
I mentioned to her that you will be here.
I'm excited that you're here because we've tried a bunch of times to meet and then you're just.
I'm no more Intel.
Sorry, Sandy, we're a couple minutes.
No problem.
Chit-chat.
Why don't I situate myself there?
Yeah. I'll have you, if you want to just talk about yourself, that's fine. Okay, it's not the dating game now. Okay, I said introduce yourselves, you know, that kind of stuff. No, I'm just kidding. I hope that during the breaks and different times that you all get to mingle a little more and get to know one another. But without further ado, I'd like to introduce Sandy. Sandy today is presenting, what is your speech called? I'm sorry. I don't know what it is, but I'm really excited that, oh, there we go. Okay, development in sensors, automation, and inventory control, which is a really great topic because this is what is pivotal in the IoT, or the industrial IoT, or Industry 4.0. So this is pretty exciting to talk about. This is where the game changers come in. Inventory control, being able to watch that, to be able to actually identify what you need is super, super important. And it comes from the bottom line, right? And those bean counters like to know what's going on at the bottom line. So without further ado, I'll let you introduce yourself.
Yeah. Good morning, everyone. You can hear me? Okay, this is have to be situated somewhere right here. Good morning, everybody. Morning. Right on. So, my name is Sandy. For people who don't want to pronounce my entire name, Sandhiprakash. Until about end of June, I was working for Intel for the last over 22 years. And about last 4 to 5 years, I've been also working in Internet of Things. I wanted to talk, I have a fair amount of slides here. I have this open. Yeah. I have a fair number of slides. My suggestion is I will leave the questions at the end unless you have a very one-line specific question, if it gets into too much discussion. Because I wanted to cover quite a bit. So, first of all, this seems like too much for 30 minutes, but there are key points I want to emphasize. One, it is all about results. And I'm going to up-level it quite a bit. I'm going to talk about data explosion. I'm talking about lean machine architecture. I'm going to talk about monitoring. What's the motivation behind this, and how can sensor help in improving precision, accuracy, and avoiding mistakes. And towards then, I'll touch the base about warehouses. So, I think we can talk all about sensors and process control and everything. At the end of the day, one fact that we cannot forget is why management is going to invest in several millions of dollars in updating your systems or creating a new system with a range of sensors. So sometimes as engineers or 4, 5, 6 levels below the CEO, we might tend to talk about sensors and we tend to forget why we are here in the first place. It is because the management is interested in investing is because somewhere in the back of their mind, they want to reduce cost. And it is a standard game, increase revenue or reduce the cost. That's at the end of the day, the bottom line that we are going to focus on. Things might be working today, but we also like them to be more efficient. And then a key fact is really knowing what's going on into your systems to be able to understand what you need to do to improve. So a basic fact from sensing is going to be really understanding what in the world is going on the shop floor or in a warehouse and be able to provide that information. That base level of information is the basic recipe for making changes once you have sensors in the system. So at the end of the day, you can talk all about computer systems and hardware, software, sensors, what have you, but at the end of the day, it's all about business results. The reason why I keep emphasizing this again and again is when I was at Intel, I had witnessed many places and come across many customers where they spend a couple of $1 million and then never saw any improvement. So it is really important that what you do has a direct impact. So the very top, the types of questions you want to ask before you put the systems in place is, what business results are you expecting? Very clear statement, are these measurable goals? What amount of, you might want to go to the moon, but if you have a budget only to go from to Portland to Minneapolis, you're not going to go to the moon. So you have to have an allocated budget, and a lot of these things require ongoing money as well, to either because things go bad or things additionally are needed. So unless this is clearly defined, my suggestion would be not enter into the then step, which is once you have those figured out, then say what sensors are required, how many, what is the specs, where do I locate them, what's the architecture, and then at the end of the day, if somebody, a system integrator, is helping you put this IoT system together, you better tie your money to making sure that there are business results that are achieved at the end of the day. If you do not achieve what you intend to achieve, you need to hold whoever is implementing that system accountable for showing results. So, you will see I'm violating many rules of PowerPoint, which is no more than 4 or 5 bullets, but I'm going to read each one of them. But whether it is inventory control or automation, at the end of the day, what you're trying to do is you want to track the inventory. If there is a cold storage, for example, where food is stored, you want to make sure that the food is not going bad. You want to make sure that stuff comes in and moves out quickly and as efficiently as possible. You also want to make sure that, at least in automation, when things go bad, you are not waiting until they are going bad, that you are knowing ahead of time. I'll give you a simple example. If you are in a power station, like what we have in Bonneville power stations on Columbia River, there are humongous, huge generators that produce electricity. And on day one, the generators the Pelton wheels are running well, but after a few months, the bearings start wearing out. Now, one stage might come when the bearings completely burst and you have to decommission the entire Pelton wheel. Wouldn't you rather have a knowledge ahead of time saying within the next 1 month, things are going to go bad. So at night when the power load is really low, you move all your load from 10 generators to 9 generators, change the bearings, and bring that back again without loss of any downtime. That's what I mean by predictive. And I can keep on going, but at the end of the day, either it has to be improving quality, speed of execution. Now, in order to achieve all of this, you need to sense. We have been humanly sensing, which is walking around and checking things, but you need sensors as extra pair of eyes, and you also have to have a machine architecture that's clean enough, that's lean enough, that not only solves today's problems, but it is expandable enough. It has key features like security and redundancy and what have you, which I'll cover, and have that architecture that's expandable. And at the end of the day, the end result is that by doing this, you're really limiting future mistakes, you're improving quality, or ensuring accuracy. Again, all that has to flow back to the results your management is expecting to achieve. If that's not happening, this is all waste. And I think a lot of people tend to forget that, especially at the engineering levels. I'm an engineer, so I'm not bad-mouthing any engineers, but we have to see where the source is coming from. So, one of the side effects is, as you add a lot of sensors, you're adding more data, you're adding more processing, you're adding a lot of communication. You need to store that data. You need to power these devices. And as you are putting more stuff in, there are going to be more points of failures. And one thing that you cannot forget, which is going to haunt all of us, people who don't know, it is predicted by 2020 we'll have 1 trillion devices and 1 trillion sensors and 50 billion devices on the planet. So a lot of these devices, some of them are going to be slow devices, meaning 50 to 100 kilobits a second, and some are going to be enormously producing data like cameras, right? All of that data has to go somewhere being processed. So the reason why I'm bringing this in, the last part, security, is once you have an IP address, you can ping those devices and you can play with those devices, especially bad people who are out there to screw up systems. So no deployment of sensors without and clearly understanding the security impact. So we just talked about creating humongous amount of data, right? How many of you have seen this pyramid before? Okay, then it will take 30 seconds to explain this. We create lots of data, especially with cameras. And like it or not, 99% of that data is useless, right? If nothing exceptional is happening, you're looking at a system for finding defects or material getting piled up, and if that's not happening, what are you doing? Nothing, right? So 99% of that data might be useless. What you want to do is not get into the habit of sending all this data back somewhere to a computing place. What you want to do is clearly where the data is originating is to convert that into information. I'll give you a simple example of what these 4 things mean. Not an industrial example, but GPS has 3 coordinates, right? X, Y, Z is what you get out of GPS. That's data. And as you are moving, you're creating X, Y, Z coordinates all the time. Now, if I'm at Starbucks, now I'm turning that into information. That data is converted into information. Now, if Sandy is going to that Starbucks Monday through Friday, same Starbucks at 7 o'clock in the morning before going to work, that gives me knowledge about Sandy's behavior. Maybe Sandy likes, you can say, I'm still not sure whether Sandy likes coffee or hot chocolate, but at least one thing that comes out is Sandy likes Starbucks. And then the wisdom part is tomorrow I might be visiting Tokyo, and the system says, hey, there is a Starbucks right around the corner, maybe you ought to go there since you like coffee. Those are the meanings, what I mean by converting it, up-leveling it right where the source is. So when you create humongous amount of sensor data, you are not loading systems, and you are making this conversion that's here right at where the end node is. Okay. So there are certain systems that are already there on your shop floors, right? There is already a lighting system, there is already a video system, there is already a HVAC system. There might be other things that are already in your environment. And most of these are not critical. I'll mention what I mean by critical. If you have 1,000 lights on a floor and 1 or 2 go bad, it doesn't make that much of a difference, right? Unless it is at a critical place. If the temperature goes by half a degree plus or minus, it doesn't make a difference. But if there is a material flow that's happening on your manufacture at a phenomenal rate of food cans being created on your manufacturing floor, every millisecond might create a problem. So today these connect to a PLC. Now, going forward though, you are going to be putting a large number of sensors and devices primarily for automation and inventory control. And there are hundreds of sensors. They have been around there for the last hundreds of years, right? All of these devices somehow connect and aggregate to an edge device, which might be in the same room, for example, right? A gateway that connects over a wide area network, and you might have a local, meaning on-premise cloud, right there and then, or companies that are represented worldwide. You know, for example, Procter and Gamble. It might be in 50, 60, 70 countries. You might be also up-leveling some of this information to a bigger cloud, maybe on Amazon or Bluemix or what have you. And then you have additional issue about syncing those clouds in case one cloud goes bad or something or that happens or the link is severed, that you still have a way to be able to get to that information. So built into this lean machine architecture are checks and balances to make sure that things are always available, right? So this PLC, the bottom arrow that you will see, is also connects to WAN. Eventually, all of these devices, including your environmental sensors for HVAC and water treatment or security videos or what have you, or lighting, they have to be connected back onto the IP network. But my suggestion at this stage is keep them separate for a while until you figure out what you need to do for your sensors in your automation and warehouse. Things on the left are working okay, they are not efficient, but they're still working. I'll give you one example and then I'll move on. If I'm coming to work on a weekend and I want to go back to my office, I turn a switch and 200 lights come because they are by zones. So I don't have individual control. And that's not what I would rather have an individual control where the lights from the entrance to my office are only lit, not the entire floor, right? That's a finer control. But at least things are working. Not so the case when it comes to automation and sensors I'm going to put into the warehouse. Now, this is just a quick expansion of the building management system. I think I covered a few points there. Precision is not as important. I mean, on some manufacturing floors, you know, a degree of temperature here and there, or humidity change from 85 to 90, it all depends upon the type of industry you are in. And then there is a tolerable lag between sensing and actuation. So if the temperature is sensed going high, by the time you turn off heaters, it is an on-off situation, so there is hunting going on. The sensing may not be always there, and downtime sometimes is okay. As I mentioned, few lights here and there being turned off is okay. Not so in other cases. So let me focus on the first part, which is the sensors and devices. So, at the end of the day, this is a little peek inside the sensor. Every sensor it has a package. It has a sensing element, which I call a transducer. There are a bunch of things that condition and there is a signal conditioning and processing occurring. Meaning, a particular sensor may not behave exactly the same way over the entire temperature range. So sometimes we might have to linearize the characteristics of the temperature, characteristics of the sensor. Second piece is, as I mentioned, the characteristics the sensors might also create noise. So you might have to convert and find ways to reduce that noise to a minimum. So you are getting true, precise information. So what I was going to suggest, you have the dot suggests that you might have several sensors. What you really need is a multi-chip package where, and I'll tell you why, the next slide I'll talk why this is important, is to have transient data storage, meaning as the sensor data is coming in, you want that data to be stored for a while, it's transient. You need data processing. So for example, I'll give you one example. The comfort of a room is a function of many things, but let me take only two things. Temperature and humidity are related together to give the necessary comfort. So these sensors are not there by themselves. They have to be correlated. Those sensors have to be fused to make a common sense. And there might be ambient audio level, for example. That might be a function of comfort. So you need local processing right there in the same package as where the sensor is. The sensor industry has come a long way. I thought I had until 10:30. No?
Well, we have 5 minutes for questions,
Okay.
so you have 5 minutes.
Okay, I'm going to flip sides. I thought I had 30 minutes, but nonetheless, that's okay. So in that sensor package, you also need to have security, information storage. If you are going to send out over communication link, you also need to have data encryption. And the sensor algorithms all working at the end node. Okay? So why, I'm going to flip those for the sensor. So part of the reason why this is you also want to have redundancy and accuracy. Let's say one sensor fails, you have to have a backup to be able to say, hey, remaining 3 sensors are going to take care and my production line is still going to work. Second piece is efficient resource utilization. For whatever reason, if a sensor device at the bottom is overloaded with 175% processing load, I should be within the domain of those sensors be able to let other sensor devices take some of the processing load. So this is what I call peer-to-peer resource utilization. And the third one is availability. At the end of the day, a sensor device, if the processing is taking too much of the processing load, you have to have an agent that in real time floats from the end node to the edge device to the cloud. So same analytics should be able to run transparently from left to right. Let me talk to the one on the right hand side, right? The gateways and clouds, right? You have to have redundancy there as well, because nothing in the manufacturing floor is sometimes a 5 or 10 minute downtime could mean millions of dollars. So you have to make sure that there are redundant gateways. You have to make sure that there is redundant resource utilization among the gateways. You have to make sure that there is communication redundancy, and you have to also make sure that there is an on-premise redundancy to make sure that processing, communication, sensing is always available. And there are enough redundant devices that issue is going to come probably in the next panel, how many. So I wanted to make sure that that indeed is true. And then what I call extreme availability, that means a complete optical link from US to Europe gets cut, you still should be able to find the data that you need to make decisions. Device monitoring, I cannot emphasize this enough, which is device monitoring is not where somebody's sitting far away. There has to be device monitoring at every single level. At the sensor level itself, so the sensor says, I'm going bad, come and fix me or change me, right? The sensor should be able to say, I'm deteriorating, come and fix me. The IoT gateway should be able to say, the number of processes that are running on my device are too many. I need to have a mechanism to reduce that workload. And this happens all the way from the front end to the back end. Although, how these device management should occur, whether it's operating system updates, whether there are analytics updates, there are profile updates, there are firmware updates, that policy is driven from the top. That doesn't mean that local people cannot have local policy. It's pretty much saying, as a corporation, I have this policy, but at division level, I have this policy. On a shop floor, I have this policy, and on a given machine, I have a specific policy, right? When nothing works, there is always a policy at the high end that dictates. And that to me is very important, because local environmental conditions might be totally different. You might have the same product being created in Minnesota as well as in Texas, where the environmental conditions might be totally different. And you might have to have different mechanisms, you might have different analytics to control local devices. So, the motivation behind that, as we said, you might have seen this. First reason why we want to have sensors is to understand what happened. If an anomaly happened, we really want to know what happened. Understand why it happened, what will happen, and B, how can I make it happen? This is really understanding what the data is all about, and eventually figuring out ahead of time if things are going to go bad, and be able to predict and maintain systems ahead of time, right? So, there are many ways sensors can help in improving precision accuracy. I already talked about redundant sensors and actuators for failures. Also, having solid analytics to be able to understand the trends so you can predict failures. Now, there has been always a debate going on in the sensor industry. Should I put $100, $200 sensors that are highly accurate, highly robust, or I can have hundreds of tiny $1 or $2 sensors? And you have to be able to make that judgment call, because there are advantages and disadvantages of using both analogies. You have to focus at the very sensor level if you want to have accuracy, to be able to make sure that you have mechanisms in the sensor, when you work with sensor vendors, to be able to say, what is your signal to noise ratio so that what I get out of sensor is accurate enough. Really understand if your shop floor is going to have variable temperature across the entire production run, how do those sensors get compensated so what you're sensing is indeed what you ought to be sensing. And the last one is fair amount of signal conditioning, processing, and final resolution A to D converters. That would also help you increase accuracy. So, last couple of slides. IoT devices for warehouses, there is tremendous amount of dollars that are flowing into a warehouse. I have a friend in Portland, Oregon, who's the chairman and CEO of a cold storage place, and tremendous amount of food comes in, and the liabilities of food rotting or bacteria being created is enormous. There are legal liabilities. So you cannot say, the qualities of Wi-Fi. Many times you're working at home on your computer and Wi-Fi link dies and comes up again. So you need to have enough dense wireless network to absorb and carry that data coming from thousands and thousands of sensors. You need to have special devices like barcodes and RFIDs for material improvement. Cameras and microphones to really understand the flow on the warehouse, when it comes in, when it goes out, really understanding the cycle time, right? Which items are rotating fast and which items are sitting there for months together. There are also a range of chemical and gas sensors, especially if it's related to food, to make sure there is no leakage. Also, again, I go back to this food industry because that's where human life is dependent on that, is about temperature and humidity to maintain the freshness of your cauliflower that might be sitting in your warehouse in cold storage. And then the most important is having location trackers, whether it's GPS, RFID, whatever you want to use, in order to understand the movement of goods and understand the transit time. We have started putting places where the material is created, it's carried over trucks or rail into a warehouse, out to your Safeways or Albertson, right? So you need to be able to understand where all your food is spending time, and while in transit. There was a case in China, where the food was being sent from one end to the other, and to save money, the truckers were just turning off the AC in between, and 1 hour before getting into the city, they were turning it on again. So the 8 hours in between, the food was rotting. But when it really ends up at the end point, people felt, oh, it's frozen, so everything is okay. But it was not okay. So you need to be able to track that food throughout the process. Okay, so summarizing, sorry for going over the time.
That's okay.
I think, as long as we are dealing with laws of physics, meaning sensors, computing, we can figure that out, right? That's pretty easy stuff, because it follows standard rules. What is difficult is really, at the end of the day, really understanding, having this page in front of you, which is, what am I trying to solve? What is the issue for my senior management? What are they expecting? Whether it is increasing the quality by X%, or reduce the wastage by Y%, or what have you. Understand, and then when you are ready to put a solution, get in writing what the budget is to put that thing in place, and also what is ongoing budget. because that will also define the choices of sensors, the type of architecture, the kind of computing systems, and let them make aware if it is not adequate, that you won't be able to achieve the results that they're expecting with the amount of budget that they're giving. Define the success criteria and check that success criteria on an ongoing basis, that indeed your food wastage has gone down from 5 to 1%. You should be able to clearly articulate that. Otherwise, IoT in general is going to fail if we collectively are not able to show the results that are expected of IoT professionals. And then worry about what sensors, hardware systems, redundancies, and as I mentioned, the last thing is also to do a follow-through. So I'm going to stop at this. I can take a few questions or whatever the next.
Any questions? Oh, tough crowd. Oh, we got one. Okay.
So when a company goes down this path, and you have to do all the backup sensors, backup cloud, all of that system. Do they usually go through a third party, or do they hire people on to do that?
A lot of places use system integrators. And I don't want to name names, but there are, the top 5, 10 system integrators. You can Google IoT and system integrators. BCG, there's Accenture, there's all sorts of people who do IoT implementations.
And then they have to keep coming back for maintenance or when things go wrong?
I've seen both flavors where somebody owns, but most people don't want somebody else to own the data. They want put the systems in place, and then they do whatever is needed.
But just so you know, it's not just the big systems integrators. It's the wonder like Malix. It's the smaller ones that are out there too that are implementing IoT solutions. A lot of them see a lot of value in it. One of the things that they're doing a lot with sensors right now with systems integrators is documentation control. So say you have a control system out there and you want to identify all of the document control on there. They're putting QR codes out there now and using sensors to do a lot of that. So there's a lot of different things that are going on in the market right now. One thing you have to remember is in control systems, there's a lot of data out there and it's dark. How do we get that data out of our control systems or our machines? And how do we utilize that to purposefully build applications that are going to be useful and save on our bottom line? So kind of think about those things.
I like the word. At the end of the day, it's a clear, demonstrable difference in the bottom line.
Absolutely. I mean, whether we like it or not, the bean counters up at the top want to see some dollar savings. And if we can save it in equipment and maintenance, then people, that's a better thing for all of us. So, and machine learning, we'll talk about that too in the next one. So now Sandy's going to stay up here as well, and I'm going to call up the other folks that are on the panel today. Paul Hein, as well as, sorry.
By the way, anybody who wants to get in touch with me, those are my coordinates there.
Yes, thank you, Sandy. You did a great job. Sandy's also going to be on the next panel that we're going to be doing here just